Alright, so in our first problem, we have example number 1. A 3 kilogram object is traveling negative 4.5 meters per second, then undergoes a variable force given by this graph here over a 5-second interval. Determine the object's final velocity. Alright, looking at our sketch, we see that the object initially is traveling in the negative direction, which I indicate here is right. And if we look at our graph, qualitatively it looks so far that you have an impulse exerted in the positive direction, which is to the left. So my final picture, I'm going to draw here a cart, again traveling to the right, but slightly slower. So negative, positive. Right, my system here is going to be the object, which I'll just call the cart, and initially I have a bar of negative momentum. Then, judging by the graph, it looks like I have a small bar of positive impulse, which at the end will lead me to, if I combine these two, a smaller negative momentum. Alright, now we have a bar for each term, so the equation will drop out. We look at this, we're going to have mvi of the cart plus the impulse of force exerted over a period of time. Note this, I'm going to say net force because that force is going to change, is equal to the final momentum. Alright, so let's figure out the impulse here. On Friday we discussed that if we take the area of the graph here, okay, we can determine the impulse exerted. So I'm going to kind of shade this in like this. We take the triangle, we get 1/2 the base, which is 3 seconds, times the height, which is positive 6 newtons. Alright, calculating that, that's going to be a positive 9 newtons per second, times second. And then the square here will be negative 4 newtons times 2 seconds, or that will give us a negative 8 newtons times seconds. Alright, so substituting the numbers in, we have 3 kilograms times negative 4.5 meters per second. If I take the net impulse, I will get a positive 1 newton times second will equal the 3 kilograms times VF. If I solve for VF, I find that VF is equal to 1.47 meters per second in the negative direction. Alright kids, that's example number 1.